So guys, good morning. We're going to talk about pre-algebraic foundations, specifically natural numbers, whole numbers, integers, rational numbers, irrational numbers. So now, today we're just going to talk about those type of numbers. And at every type of numbers, there will be like examples, what does it include, and what doesn't include, what doesn't include, and the definition of every type of numbers. So let's move on. So natural numbers. Guys, when you think of natural numbers, they're just basically counting numbers. When you think of number one, two, three, four, five, till hundreds, even thousands, those are counting numbers. They're all they are always positive. They're always positive. And they do not include the zero, negative numbers like 1, -2, -100, fractions like 1/2, 1/3. They do not include those type of numbers. Or even decimals like 0.3, 0.5. They, they just contain counting numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until so on and so forth. So I think that discusses the type of number of what's inside and what describes a natural number. So let's move on. I'll just give you guys 1 minute to answer this question. Hi guys, I'm back. So are you guys done? So let's answer it. As five is a natural number. The answer is given there. And 12 is not. Oh, it is a natural number. Sorry, it is a natural number. It it is a natural number. Wait, it is a natural number. Zero is not a natural number. 100, it's a natural number. -3, it is not a natural number. 1 is a natural number. 25 is a natural number. 2.5 is not a natural number. And 9 is a natural number. 1/2 is a fraction, so it's not a natural number. Always remember, guys, there cannot be no decimals, no fractions. No decimals, no fractions, and no negatives. Wait, no negatives and no zero, and zero. Okay, so let's move on. So, what are whole numbers? Whole numbers, they are basically natural numbers together with zero. Whole numbers, they do not include like natural numbers. Natural numbers, they do not include negative numbers, uh, fractions, or decimals. So, in simple terms, not whole numbers are natural numbers with zero. That's everything that you need to know. And let's move on. So whole numbers practice. I'll give you guys 30 seconds. 1 minute was too much earlier. Hi guys, I think you guys are done. So let's start. So zero, a whole number. It is a whole number. Is eight a whole number? Since it's positive and it is a natural number and it's a counting number, so it's a whole number. 15 is a whole number. Negative 1 is not whole number. Remember guys, whole numbers, they just contain positive and zero, and they do not contain negative numbers, fractions, and decimals. So definitely not a whole number. So the next is 20. It's positive, and it's a natural number, and it's a counting number. And so, yeah, it's a whole number. 3.7, not a whole number. 100, it is a whole number. 1/4, it is not a whole number. It is 2, it is a whole number. And -10, it is not a whole number. Always remember, guys, whole numbers, they're just negative, they're just positive numbers and the zero. They're just basically natural numbers or counting numbers in other terms, and they do not contain the zero, fractions, and decimals. Decimal. So let's move on to the integers. Integers are numbers that include positive and negative and zero. The difference between integers and whole numbers is whole numbers, they just contain positive and zero, while integers, they contain negative numbers, zero, and the positive numbers. So the same rule applies to the integers where they do not include fractions or even decimals. They do not include those. Integers can be negative, positive, or zero. Like example in a sentence, like the -3 in degrees, the -3 of the sentence is an integer. So let's move on. Is -5 an integer? Oh, wait guys, I'll just give you guys 30 seconds to answer this. Sorry, I apologize. I think that you guys are done. So let's answer. So is -5 an integer? It is an integer. Zero an integer? Remember, integers have zero, so it is an integer. Is 9 an integer? Integers contain the positive numbers, so it is an integer. Is 2.5 an integer? No, it cannot be an integer since it's a decimal. So definitely no. Is -12 an integer? Yes, it is an integer. Sorry. Is 1/3 an integer? It is a fraction. So it cannot be an integer. Is 100 an integer? Yes, it is an integer. Why? Because it is a positive number and it is a natural number or or a whole number. So it is an integer. Is -1 an integer? Yes. Is 4.75? No. Is 25 an integer? Yes. is an integer. So, so let's move on to the rational numbers. Rational numbers, they can be written as a fraction. They can, and where the numerator and the denominator are integers. So if you remember integers, there's positive, there's negative, and there's a zero. But the denominator cannot be a zero. If you remember fraction, guys, there's always a numerator and a denominator. The numerator is always on the top here, and the denominator is always on the bottom. So so examples of fraction is 1/2, 3/4 here, and also I forgot to mention is that rational numbers, they contain also decimals. Decimals are allowed here. So 0.25, 0.52, -7, and 4.75. So important note, guys, all integers are rational numbers because they can be written as fractions. So let's move on. Oh, further examples of rational numbers, I forgot to mention. Uh, 2, that can be 2 over 1. -5 is -5 over 1. And 0 over 1. Or rational numbers, basically, guys, is decimals that end or repeat. So, for example, like 0.33 that go on forever, that repeats, they are rational numbers. 0.5 and 0.75, or they're basically rational numbers because they end or repeat. I think that's all you need to know, guys. So let's practice rational numbers. I'll give you guys 1 minute since this is more difficult for you guys, considering you will identify whether if it's rational, because you will identify also if it's repeating or it ends. So guys, I think you have answered all of it. So let's move on. So is 1/2 a rational number? It is a rational number because it ends and it is an integer. It's a positive. Wait, so next is 0.75. So I will put the chapter. So 0.75. Since it is a terminating decimal, or it can be written as 75 over 100. 75 over 100. It is a rational number because it is terminating, which it ends. So that's a rational number. So negative 4, it is a rational number because they can be written as fraction as well. So uh, if you put negative 4, so negative 4 is going to be negative 4 over 1. Since it can be written as fractions, it is irrational. Not can, it is irrational. So 4 is irrational. And 8. 8 is a terminal. 8 can be written as a fraction and uh, it is terminating. So it can be written as 8 over 1. So it is rational. 0 is rational because it can be also written as a fraction as like the example earlier, 0 over 1. So it is irrational. 0.33 or 0 or 1 over 3 or 1 over 3, it is rational because it is repeating all the time, guys. Remember, repeating decimals are rational numbers. The square root of 2, the square root of 2, when you calculate this, it's gonna come out as like 1.41421356. This alone shows that it repeats, but it never ends. Oh, I mean, it never repeats and it never ends. Repeating is like 0.11111, but in this scenario, it doesn't repeat and it doesn't end. So it is an irrational number. Yep, definitely not irrational. Oh, pi. Pi is irrational all the time, guys. Why? When you calculate pi, you're gonna see a lot of non-repeating numbers and it never ends. So it's irrational. Negative 7 over 3, it is rational because it is written as a fraction. And 5.25, it is rational because it is written as a fraction. All the time, guys, remember in uh, rational numbers are decimals that are repeating and that is repeating and decimals that are repeating and non-terminating, and also it can be written as a fraction. So rational numbers can be written as a fraction, it repeats, and it ends. So that's all you need to think and remember in rational numbers. So let's move on to irrational numbers. So irrational numbers, they're basically the opposite. So their decimal form, that's what I mean earlier, their decimal form, it does not end and it does not repeat. So it keeps on going and going and going forever without repeating. Like, for examples here, like the pi. When you calculate this on your calculator, guys, if you check its decimal format, it's the the value of pi itself, it doesn't repeat and it does not end. It's really long. So irrational numbers, furthermore, there's there's more examples of irrational numbers like square root of 2, the square root of 3, square root of 5, which does not repeat and it doesn't end. And important note, guys, always remember it is non-ending and non-repeating, which is the opposite of rational numbers. Irrational numbers, it repeats and it ends, terminates and it ends. So let's practice. So irrational numbers. I'll give you guys another like at least 1 minute to answer this. So let's go, guys. Let's answer this practice. So is the square root of 2 an irrational number? Yes, it is an irrational number because it doesn't end. Its decimal format is it doesn't end and it does not repeat. So it is an irrational number. The, the value of pi, it is an irrational number. Square root of 3, it is an irrational number. 1/2, it is a rational. As I've said earlier, it can be rational numbers, they're fractions, and yeah, they're it yeah, basically guys, it's a fraction and it's can be neither positive or negative. Always guys remember, if it's a fraction, uh it is always gonna be like a rational number. But always remember, the value of the denominator cannot be 0. Wait guys. For the next, it is 0.75, it is irrational. Square root of 5, it is irrational. -4, it is rational. It can be written as a fraction. Uh, and next is 2, it is rational. 7, it is irrational. 0.33, okay, it is rational because it repeats decimal format, it repeats, and it ends. So in conclusion, guys, lock in. So natural numbers are counting numbers. Whole numbers are counting numbers, including zero. And integers are positive numbers, positive, negative, and zero. And rational numbers can be written as fractions, and irrational numbers cannot be written as fractions. And half decimals that never end. Also remember, it doesn't end; it keeps on going, but it never repeats. So I think that's for all of this video. Thank you. Thank you.